All right, let's talk about one of the biggest challenges in AI today. It's memory, or lack thereof. We're going to dive into how we can make AI smarter, way more factual, and just incredibly useful. We're on a mission to build an AI that doesn't just guess, but actually knows. So, you've probably been here, right? You ask a chatbot a question, and it gives you this super confident sounding answer that is just completely, totally wrong. Maybe it invents a historical fact or gets a recent event all mixed up. This is the exact problem that's kind of holding AI back from being a tool we can really, truly trust. In the AI world, there's a specific name for this. It's called a hallucination. It's what happens when a large language model or an LLM just generates false information. Either its training data is out of date or it's just trying its best to fill in the blanks, and that is the exact problem we are going to solve right now. So how do you fix an AI that has a tendency to, well, lie? The solution is actually pretty brilliant, and the best way I can think of to describe it is like giving the AI an open book exam. Yeah, instead of forcing it to memorize the entire internet, we just let it look at the notes right before it has to answer. Now, the technical term for this open book method is Retrieval-Augmented Generation, or just RAG for short. And believe me, it's a game-changing technique. It connects the AI's amazing language skills to a specific external knowledge base, like, say, your company's private documents or the latest news feeds. This forces the AI to ground its answers in actual, verifiable facts, not just its general and sometimes outdated training data. That all sounds great in theory, but, how does it actually work? Let's break down the play-by-play. The process is actually surprisingly straightforward, but it is incredibly powerful. So it all starts with your question. Let's go with, what's our new return policy? Then the system retrieves the exact, most relevant snippets of text from, say, your company's internal PDFs. Now here's the crucial part. It augments your original question by basically pasting that factual text right into the prompt. Finally, it hands this new supercharged prompt to the LLM, which now has all the context it needs to generate a perfect, factual answer. And the benefits here are just huge. You get incredible accuracy because the answers are based on fresh, specific data. That means hallucinations, they practically disappear. You can even get source citations, which builds a ton of trust. And you know what else? It's really cost-effective. You don't have to retrain a massive model every time a policy changes. You're basically turning a generalist AI into a highly trained specialist on your data. Okay, but that brings up a huge question. If you have thousands, maybe millions of documents, how does that retrieval step find the exact right piece of information in a split second? A simple keyword search is just not going to cut it here. This is where the real magic happens. See, we need to go way beyond old-school keyword search. Keyword search is literal. If you search for the word return, you only find the word return. What we need is semantic search, a search that actually understands meaning and context. With semantic search, if you look for return, it also finds related ideas like send a product back or refund policy, even if the word return isn't in the text at all. So what's the engine that powers this kind of sophisticated, meaning-based search? It's something called a vector database. And this right here is the second key piece to our whole AI memory puzzle. A vector database is a totally special kind of database, built from the ground up for AI. It doesn't store words or images like you'd think. Instead, it converts everything into these long strings of numbers called embeddings. You can think of these numbers as a mathematical signature for what something actually means. This lets the database find things based on how conceptually similar they are. I think the best analogy is a magic library. In a normal library, books are organized alphabetically by title. But in this magic library, books are organized by their core ideas. So a book about traveling to Mars would be right next to a book about rocket fuel, even if their titles start with completely different letters. It's all about the meaning. So here's how it all clicks together. First, every little piece of your data, every sentence, every paragraph gets converted into these numerical vectors, these embeddings. Then the database creates this super fast index, which is kind of like a map of all the meanings. So when you ask a question, your question also gets turned into a vector. The database then just has to find the data vectors that are mathematically closest to your questions vector on that meaning map. And that's the magic behind finding refund policy when you only asked about a return. Okay, so we've talked about the open book process of RAG and the magic library of vector databases. Now, let's put it all together and really see why this combination is such a massive leap forward for artificial intelligence. So let's lock in this whole concept with our complete analogy. The LLM, the large language model, That's the brain, the skilled essay writer. RAG? That's the process. It's the open book exam rules that make sure the writer uses the right facts. And the vector database? That's the tool. It's the magic, meaning-based library that lets the writer find the exact right piece of information instantly. And the payoff for all of this? It is enormous. We are talking about AI that has true contextual understanding. This opens the door for way better recommendation engines, deeply personalized customer experiences, and business tools that you can actually trust with your company's private data. This isn't just a small upgrade, it's the future of how we search for and interact with information itself. So when you think about it, what we're really building here is an AI with a nearly perfect, instantly searchable memory. By combining the incredible reasoning of LLMs, the factual grounding of RAG, and the lightning speed of vector databases, we're creating a whole new class of AI. And that leaves us with one final, really exciting question. Once our AI can know anything, what are the truly hard problems we're finally going to be able to solve?